Okay, so here we are with Unit 5A, Lesson 8, and we're going to be looking at a continuation of percentage composition, but with a different type of compound. It's a compound called a hydrate, and it's a very unusual compound. It is an ionic compound because they all contain metals, but what makes it weird is that the salt, the ionic compound, also has water molecules that are attached to its structure, so it's called a hydrate. If you remove the water from the hydrate, it's now called an anhydrate. That's one of the things that you're going to be doing in the lab on percentage of water in a hydrate. You're going to be given a specific sample of a compound, a hydrate, let's say 5 grams. You're going to heat it, which will drive the water molecules off of the ionic compound, let it cool, and then measure the mass again. The mass at the end is going to be the mass of the anhydrate, in other words, with the water driven off. And if you take the difference between the two masses, that will give you the amount of water that was actually attached to the ionic compound. And from that, you can figure out the percentage of water using the formula that we used for the previous section. So technically the water is not really bonded to the compound, it's just attracted to the ionic compound because the fact that the ionic compound has positive and negative ions and the molecules attracted to it. So let's just start out with an example. If you look at this first one here, this is what a hydrate looks like. This would be called, and we already know this, this is sodium carbonate, and you would say pentahydrate. The penta means 5, and the hydrate means water. So this is sodium carbonate pentahydrate. They don't ask you to name these on the Regents exam, just in case. So the first step you have to do is you have to still figure out what's called the gram formula mass. Let me change this to a different color because it is hard to see the color, or I can't get it to change color. Let's just go to black. So the gram formula mass, and when I say the gram formula mass, you have to do this entire compound here. So we'll do it quickly. I have sodium, carbon, and oxygens. I have 2 sodiums. I have a carbon and 3 oxygens. And we're going to do the water separately. I have the H in the water and the O in the water. Now you have to be careful because you have a 5 in front. That means literally you have 5 H2O molecules. So in order to figure out how many H's, you have to multiply the coefficient by the subscript. So that means I actually have, in the water, I have 10 H's and 5 oxygens. And we're going to do both of these separately, and you'll see why. The mass for sodium is 23. The mass for carbon is 12. And oxygen, of course, is 16. And again, we know that hydrogens are 1. And again, oxygens are 16. So let's do these. That's going to come out to 46. That comes out to 12. That's 48. Now let's do the water part of it. This comes out to 10. And 5, that's 56. That comes out to 80. Okay? So if you add all of this up, the total comes out to, I believe, 196. That's the whole, if you remember from the equation before. So the percentage of water, we already have one number. We have the bottom number, that is 196. We have to figure out the part. Well, we're looking for the percentage of water. The water is this whole thing here, the 10 plus the 80, which is 90. So we would have to do 90 divided by 196 times 100, and that's going to give us approximately 46% water in this hydrate. That would mean that the remaining 54% represents the anhydrate. In other words, this part here would be 54%, and this, including the 5, would represent 46%. Normally they don't ask you about this, they want to know the percentage of water. So it would be 46 for this one. Okay, next page. If you look at this one here, let's do black again. Alright, so we have another one. We have barium chloride dihydrate. So we're going to do barium, chlorine, the hydrogen, and the oxygen. Okay. So I'm going to just save some time that the total, the percentage of water, the whole at the bottom is going to be a large number. It's going to be 243. You would have to get the gram formula mass. I'm not going to go through this to make this shorter. The water is only going to be 36 out of that 243 times 100, so you guess you're going to get a small percentage, and I believe it comes out to, in this particular hydrate, comes out to only 15% water. Okay. If you look at the bottom here, you have two more examples. I'm not going to go through these here just to keep the video relatively short. You do need to do these. This one and this one, find the percentage of water in that one and find the percentage of water here. This one, by the way, and if you're paying attention, this is called Epsom salts. And we're going to use this hydrate in our lab. So the number that you get for this is extremely important because you're going to have to use the percentage of water in this one in your lab. So please keep that in mind. And that is the finding it using the formula. But what you're going to be doing in the lab is you're going to be going one step further. What about if you're going to be doing it, as we said, in the lab and you have to use your data? Well, let's take a look at what we have here. We have, here's what we have. And what you're going to be using is a crucible. So your crucible is like a little tiny bowl, cup. In that cup, you're going to put the hydrate. The mass of the hydrate is about, it's pretty large, 45.3 grams inside the crucible. You're going to heat it, right? So here's your little Bunsen burner. Woo-hoo, woo-hoo. After you have heated it, your mass is now gone down to 39.8 grams. Notice the difference. That's because that's the water that was driven off. So if you take the difference between these two numbers, right? So the 45.3 minus 39.8 will give you, that's 45.3, that's 5.5 grams of water was driven off by heating it. So now we can find the percentage of water using our data, right? We do have the part, which is 5.5 grams. The total is this, 45.3 times 100. And if I use my trusty calculator, it's 5.5 divided by 45.3. So you can see it's going to be a relatively small number. It's going to come out to approximately 12% water. So the remaining 88% was the anhydrate. That's one of the things, and this is what you're going to be doing in your lab. Now if you look at the one at the bottom, it's slightly different and a little bit more confusing. Why? Because they're giving you the mass of the crucible that you're heating it in. You don't really need that, right? So this is the crucible and the hydrate. This is the anhydrate. So it doesn't really matter what you don't really need to subtract the crucible mass. So we need to find out what the mass of the hydrate is. So we would find first, that's the crucible and the hydrate, and we're going to subtract the crucible from that, which would be 5.13. So the mass of the hydrate, you notice kind of, if you do this, how these cancel out and you're left with just the hydrate, that is going to come out to 2.01. So the hydrate is 2.01, right? So 2.01 would be our bottom number, 2.01. Now we need to find the mass of the water. And if you take the difference between these two, that's going to be the mass of the water. So if we have 7.14 minus 6.29, and we get looks like 0.85. So if you subtract these two, you're going to get 0.85. That's the water, that's the part. So it's 0.85 times 100. So it is going to be about 42% water. So this page, this slide, this is what you're going to be doing in lab. But you do need to know how to do percent hydrate just from the formula because they will ask you that on the Regents. And that is the end of this lesson.